course. It's the essence. It's the epiphany of exponential creativity and innovation, right? Like I always like to say, when you move your mouse, there's like 30 different layers of software that are involved in every touch of your mouse, and you don't care about that, right? Like that's a completely abstracted from. You don't even know that this mouse is like a little point, like a little bitmap that's drawn on your screen, and it has these little. And I used to draw these things. I remember when I was a kid, it was like my hobby, right? Like, but that's the beauty of abstraction, right? Like, and that's why I love software in a sense.
Elad Ben Israel, welcome to Software Engineering Daily.
Hi, nice to be here. How are you?
Not too bad. So we wanted to run through your life story and how you ended up doing what you do now. So you said that you started out as a 90s PC kid. What does that mean to you?
Embarrassing to say, I was 1980s PC kid.
Wow.
I think I started programming around 1990. So it's
was that BASIC, or what was the language then?
I think it was Pascal in BASIC back then, and then a friend told me, you got to learn C. C is the language that will teach you what computers are. And so I actually recall like buying like a C book, like a classic C book, when I was like 13 or 14 or something like that, and never looked back, I guess.
Yeah, I can absolutely identify with that. C was also it was my second language. My first language, I'm also a bit embarrassed to say, is PHP. But I'm really proud of having, well, not proud, but I'm really happy that I have learned C, because it makes you really understand the concepts of programming under the hood. Well, to a certain level. I still admittedly don't know anything about how assembly works, for example. But, I know how to implement a linked list, which means I know the trade-offs between different data structures.
I remember like having like understanding pointers.
Yeah,
was a huge kind of coin drop for me, right? Like, it's because I think like that's where C is basically, you're so close to how memory works and being able to understand what a pointer is, and it just like kind of like unveils the mysteries of what is a computer, right? Like, and so there was something that was really magical about it.
Yeah, I remember when I first learned about pointers, I wrote a C program, compiled it, and all it would do is declare a variable and print the address in memory. And then I realized if I started it 5 times, 4 times out of 5, it was the same address, because when I closed it, it was freed up again. So then I wrote a second C program, hard-coded that address in, and then incremented it by 1, and then did a thing in the other one where if I pressed enter, it would print the value again. And this was before like memory space isolation and randomization, and it actually worked. Yes. It's like one process could just patch into the memory of another one. I'm like, this is crazy.
Yeah.
So go on. After that, it says
to these days. Sorry, go ahead.
No, it's all right. Tell your story however you want to tell it. It says here you went to the Israeli army afterwards. Is that related, as in a sort of technical capacity as well?
Well, yeah. I mean, the Israeli army surprisingly has a pretty large amount of software engineers in it. It's mandatory service, so obviously the cheapest labor ever. And it's actually amazing. I remember when you join the army, you kind of go through you're gonna go through like some screening process for different types of units. And I had some programming background, and for me it was like, a dream come true to go and have spend all these years, and you have to spend at least 3 years in the Israeli army. Eventually I spent 6 years in the Israeli army. But I was doing programming. So for me, it was just like Disneyland, in a way, hard to, it's always kind of conflicting, because an army is generally, but it is a defense army, and I spent most of that time building defense systems that are, using software, and it was great. It was like an 18-year-old kid getting to work on really interesting technology and working in a team and understanding what it means to work in a team and build software together with other people. It was actually this unit that had both hardware and software engineers working together and building things. And so for me, it was just an amazing school.
So what was the culture like, in the sense of the culture of the programming teams? That's always one of the things that interests me as a DevOps the most. Was there a lot of mentoring? Were there good practices like code reviews, peer reviews, or was it as hierarchical as you imagine the army being?
So I started with like a 6 months training course, programming training course, which was like military training, boot camp style, 10 hours, 12 hours a day with like uniforms and cleaning up the toilet type stuff. But all throughout that day, you're basically learning how to program. And this course specifically is designed for people who don't have background in programming. So it's actually starting from like first principles. The first few months, you're just drawing algorithms on paper, like you understand how to create like flow charts. And so it's actually very well designed to take in hundreds and hundreds of kids that have like potential to be good programmers and turn them into like first grade practitioners. So it's, in a sense, it's a very, pragmatic, practitioner-centric training for programming. And they really teach you all the, best practices on how to build production-grade software. So for me, it was like a very good foundation. And then as you go and, if you finish your training and you go to the unit, you realize the world is like 100 times more messy. And all the stuff that you've learned is basically really nice in training, but then reality is, and again, it depends on which unit you go to. Like every unit is very different, and so. But I think like for me it was like a great experience because I could also, I already came with some background, and I already had like lots of opinions on how to build software, and obviously I thought I was way smarter and way more experienced than I was really. I actually was. But in that environment, it was like really an opportunity to test my ideas and test my opinions and try out new technology. And it was really fun. And I'm still in touch with some of I actually have someone in our company is a guy that I served in at unit with a friend of mine, is one of the best software engineers I've ever worked with. So.
Small world.
It's not a small world, right? Like we know each other, so obviously that's not a coincidence. But the fact that I still feel he is one of the best programmers I've worked with is probably a good indication.
Yeah, so strong foundations, I think, go a long way. So do you feel this helped you get a job after the army as well?
Yeah. So when I finished my service, I basically spent some time doing some freelance work, kind of like, doing some contracts and embedded software and Linux and low-level networking stuff, which was what I was doing in the army. And then I joined a startup company that had some folks from my service that were involved. And so it's definitely an amazing, an amazing start for a career. And, as you're in the army, you're like, okay, everything looks very dramatic and very substantial. And then as my career progressed, I realized this was great. It was a small piece, and but it's a great start, definitely.
So let's talk a bit about your career progression, because you've worked for some major companies, Microsoft, Amazon. You've worked on AWS. Tell us a little about how you fell into that or worked your way into that.
So basically, after one of the things one of my realizations, as I just mentioned, was that my army service wasn't a great school for like building, I would say, large scale, high level software, right? Like it was very kind of low level, very bottom up type engineering in the sense. And I felt I needed like to learn from the best in the sense. Like I wanted the best school for like building real world complex software. Mm-hmm. And Microsoft had just started their Tel Aviv site at that time. And so I interviewed and started working there and spent about 5 years working at Microsoft, which was really, really fun and really interesting. And I feel like in that sense was the best, step for me, because it gave me another layer of education and training and experience on like building software in like large teams, and way more pure than kind of like this low level embedded stuff that I've done in the army. And at that time, Microsoft was still not even in the cloud, and Azure was just kind of starting. But distributed systems were becoming very popular and very, Google has been publishing a lot of research on that, and so we actually I was lucky to be in a team that built, today we would call it a private cloud platform in a way. It's basically kind of like building a little cloud from the ground up. And for me as a developer, it's always like when you are able to kind of go through building something from the ground up, from the lower layers to the higher layers, your understanding of it is incredible. And so kind of reading research about distributed storage and reading research about, horizontal scaling and implementing those things as in a big team. And so to me, it was great. It was just the perfect opportunity to learn what the cloud is from first principles in a sense.
Yeah. So you mentioned that in the army you did loads of low level networking stuff, and I assume it's really important that people who work in actually implementing a cloud understand these low level considerations, because as a cloud user, we don't need to understand them anymore because they're abstracted away from us. We just say stuff like, I want enhanced networking, and now my networking is faster. But how does that work? Nowadays, most cloud engineers don't know because they don't have to know. But of course, there has to be someone in the stack who does understand. All of these things.
I mean, it's an interesting observation, because what we're doing today is I'm building a programming language for the cloud called Wing, and we'll talk about it in a second.
Absolutely.
But one of the ways we're talking about it a lot is we're saying cloud engineers don't really need to care about the low level details of the cloud, but they have to, right? Like the reality of the cloud today is that the mechanics are leaking into the developer experience, and that's one of the things that we're trying to solve. But in a sense, if I'm looking back on my career and kind of like my experience as a developer, I feel like I've always really liked understanding how the lower layers work. And so there's this really interesting kind of dichotomy between understanding the lower layers and building on top of high-level abstractions. And I feel like I think good engineers, my experience, in my career working with great engineers has always been that they understood that the fact that they're using high-level abstractions doesn't mean that they don't need to understand the lower layers and have empathy to the lower layers.
Yeah, absolutely.
It still doesn't mean that they need to tweak the lower layers every time they're building higher-level applications. I think like that's so definitely an interesting observation.
Yeah, no, I think it's the only way that we can build applications as complex as we do nowadays. If you think about object-oriented programming, there are lots of things that are completely abstracted, and it's certainly not as efficient as if you build the same application flawlessly in assembly or in plain C, for example. But just the human effort involved and the possibility for mistakes rises exponentially the lower you code, I would argue. Yeah,
of course, it's the essence, it's the epiphany of exponential creativity and innovation, right? Like I always like to say, when you move your mouse, there's like 30 different layers of software that are involved in every touch of your mouse, and you don't care about that, right? Like that's a completely abstracted from. You don't even know that this mouse is like a little bitmap that's drawn on your screen, and it has these little. And I used to draw these things. I remember when I was a kid,
wow.
It was like my hobby, right? Like, but that's the beauty of abstraction, right? Like, and that's why I love software in a sense.
There's a lost bit of computer art. No one uses custom cursors anymore, I think, nowadays.
It is lost.
I used to work, one of my first student jobs, I used to work with someone who used custom Windows cursors. So everyone else's computer was just a standard white arrow on Windows, and his was a big bumblebee. And it is just so weird. But yeah, I feel like that could do with a revival, having custom cursors that don't look too awful and don't take away too much performance or attention, but be a nice personalized touch. So after Microsoft, you worked for Amazon and eventually AWS. Do you want to talk about that for a bit?
Yeah, I mean, I after Microsoft, spent a couple of years traveling actually, and did some freelance work. Actually, my boyfriend at the time was my husband today. Convinced me not to take a laptop with me to our when we flew to China. And for me, it was like I realized it was the first time since I was about 10 that I didn't have a keyboard next to me, right? Like in close proximity to my hands.
Was that because of security considerations? Was that not taking a
not
laptop?
At all. No, it was like
just so you could switch off.
Yeah, exactly. So I could actually travel and disconnect
and spend quality time together. And yeah, okay, I understand.
Spend quality time together, and it was great. It was actually a really good call not to carry a laptop with me as we traveled. But after about 7 or 8 months, we flew to San Francisco and spent about 5 months in San Francisco. Went to Burning Man, and then I bought a laptop because I was like, "This is enough." So I think since I was 10, I think I spent about a year maybe less than a year without a laptop, without a keyboard. And so yeah, as we were traveling, I was kind of doing a bunch of kind of, today you'd call it nomadic hacker or something like that. And I loved it. It was really great. Had some opportunities to partner with some startups and help them, when their initial stacks and some iOS programming, which was really fun, and some web development and backend stuff, and always been really like to kind of cross the layers and learn new technologies and new tools. And at some point, this guy that I worked with at Amazon reached out. We were in Seattle visiting some friends, and he reached out and he was like, "Hey, I moved to Amazon, and I'm starting this new project. Maybe, I don't know, come here, come listen." And we were in Seattle, and so we met for coffee, and he was like, "So it's still, undisclosed. We're not, we haven't talked about it yet, but we're building this drone delivery system." And at that time, drones were you would think that they came from like the aliens or something like that. I remember like watching these drones and like bewildered by this magical thing, still in mid-air, and having that like combined with the Amazon, vision of like drone delivery. And that was, at the beginning of the drone hype. So everybody was sure that within 2 years, we won't be able to see the sky because everything's going to be filled with
Yeah.
drones. And so 10 or even more, 10 years in, I think they just did their first production delivery, like a month ago or something. But back then it was really inspiring. It's still very inspiring. I still think it's a worthwhile effort. And so he said, come to Seattle. We'll pay for all the expenses, after you finish your travels, and spend a bunch of months, see if you like it. If you like it, you can stay. And I remember, and it was like, I didn't have anything, I was kind of freelancing, and we were thinking of going to Burning Man again. And so it was like nicely aligned with our plans. And spending some time in Seattle in the summer is beautiful. It's not fair. It's not a fair. And I remember, starting my first day, they kind of take me to this hangar that they leased downtown Seattle, and I remember going into that hangar and kind of like feeling like Alice in Wonderland. Like they just like poured every type of hacker maker equipment into like this huge room because they didn't even know what they want to build, what kind of things they need, what kind of materials. And so for me, it was like, it was perfect. I'm a maker at heart. I mostly do software making, but I feel like I'm a maker at heart, and I love to build things, and, kind of going into that type of environment with like amazing people from like across the industry that they brought in to try and build this thing was obviously a very interesting opportunity. And after a couple of months hacking on drones and prototyping and fooling around, which was really fun, I also realized Amazon was a really interesting company. I mean, I've kind of learned to started to learn about the culture and the philosophy, and it was very refreshing. It was very different than the Microsoft philosophy. It felt like I might feel comfortable in this environment where it's kind of embracing chaos and embracing independence, which is something that for me was a little harder at Microsoft. Felt very regimented, very structured, very hierarchical, where Amazon was kind of like celebrating innovation and celebrating
Failing
people's
fast and such.
yeah. And so it was, and obviously this project was really inspiring. So joined Amazon, found myself again in corporate America. I don't know exactly, wasn't in the stars initially, but felt like an interesting opportunity. And it kind of, in a sense, full circle a little bit with my army service, because it was again going back to like low-level, real-time software, multidisciplined environment where you have like people doing hardware and software together. So in a sense, it was like I felt I'm using some of the skills and experience I had in my army service. And so I spent a bunch of years there.
So you've
really
worked on the drone program at Amazon, but you've also worked on another project there.
Yeah, and after a couple years, I realized it's probably going to take 10 more years before this is going into production. And it got to the point, it basically got to the point where I felt that I really wanted to do stuff that's in production, that has real users. And Amazon is the perfect company for that, because there's a company that does a lot in production, and there's a lots of scaling, and I really was interested in the cloud and really wanted to make sure that I have a really good understanding of how the cloud is evolving. It kind of felt like it's a great opportunity, but I'm actually not doing anything that's related to the cloud when I was working for Primaire. And so after a couple of years, I found this new project with the Amazon Search, the folks that are responsible for the search experience at Amazon, on Amazon.com. So moved over to work with these guys, which was like almost the mirror image from an engineering perspective. It was like, this very, very large scale system, incredible responsibility to like serve all of the traffic that Amazon had, basically, the front door to Amazon.com. Everybody uses search.
Of course.
System was designed 15 years back. And so like lots of legacy architecture, which you had to appreciate, right? Because it's working. And so to me, it was like, in terms of like problem solving and engineering thinking, was really amazing and interesting. And the folks there were very experienced engineers, have been, kind of shepherding this system for a long time. And so that was my next gig there.
So again, an interesting trade-off between low level in order to make sure that stuff is performant and fast, but also making sure that it can scale unbelievably largely.
Yeah, exactly. So it's like cloud, distributed systems, real-world production, real-world problems, right, and challenges.
Elements of big data, I imagine.
Yeah, working a lot with working with the catalog, with the Amazon catalog, which is over 1 billion items, and having to be able and being able to like find things within that catalog and realize what's the right architecture there. And I was involved with a project that tried to restructure the search index and optimize some of the hardware costs, which were going in the wrong direction in a way. And the opportunity there was interesting because we were building this microservice that supported the search cluster. And that microservice was kind of like this big data streaming analytics system which sat on the website event firehose. So it basically saw all of the events that happened, or that the people clicked on items and ordered things, and then use this information to identify which products in the catalog are more likely to be needed in search results. So it's kind of like this tiering system. And the interesting thing there was that we built it. There were a lot of interesting things there, but one of the interesting things there was that we built it we kind of leaned heavily on AWS, obviously.
So that existed at that point. What was the, what was the scale of AWS at that point? Which were the newest services? What was the kind of stuff that AWS could do at that point? And what was the stuff that it couldn't do yet? I think that's because AWS is evolving like crazy, obviously. I always tell my friends that nowadays you can rent a satellite ground station by the second on AWS, just to make non-technical people understand how unbelievable the cloud is nowadays. So at that point in time, where would you position AWS?
I think it was kind of like the rise of serverless in a sense. Back then, Amazon.com, the retail business, was still mostly hosted on EC2 machines. And in a sense, it's kind of like the migration from before AWS, because Amazon.com existed before AWS. And so when AWS started and EC2 started, what happened is that Amazon.com kind of lifted and shifted their data centers into EC2, but they didn't change a lot about the higher layers, the top layers of the stack. So the applications were still built in the same way. They were just running on EC2 now. And so they could leverage some of they could enjoy some of the economic, aspects of using EC2. And in a sense, that's the origin story of AWS in a way. But most of those services still weren't able to weren't leveraging most of the AWS portfolio. And at that time, Amazon was, and still, but at that time, Amazon was going through this really, really interesting process of enabling Amazon.com teams to leverage AWS services to build the internal services, the services that were part of Amazon.com. And by enabling those things, when people like me came and wanted to build this new microservice, suddenly we could build them with Lambda and with DynamoDB and with Kinesis and with technology that wasn't very popular, it wasn't very widely used internally at that time. And which is actually one of the beautiful things about how Amazon operates and, how this innovation flywheel works. By enabling these internal teams to use these external services, they're able to understand how these things actually work in real, they're becoming their own design partners in a way. And so that was like, I would say, the rise of serverless, because that's when Amazon had started to kind of seriously consider using serverless for their production systems. And in a way, that was also the reason. So we used serverless for this project because it was like, hey, I don't want to deal with servers. I don't want to deal with scaling the system and monitoring CPU usage and stuff like that. I just wanted to run load, and the load was huge. From day one, we needed to support incredible capacity, which was very interesting. It's usually not like that, right? Like usually start slow and build up. In this case, from day one, we needed to be able to process the entire fire hose of Amazon.com events in the US, right? Like that was like day one. And so it was really fun to kind of have this really clear constraints that were not some hypothetical, maybe in 2 years we'll have a lot of traffic. No, day one. And so that made it really clear where the total cost of managing fleets of servers versus using something like Lambda. It was so clear to us because it was like, being able to elastically scale was almost a requirement. And so what happened there is we use CloudFormation to provision all these services, all these resources. And it was the first time I've built something like that, which was, real world, large scale. And I found myself copying and pasting YAML for a month.
Yeah.
And to me, that was like something felt wrong, right? Because as a developer, I'm already used to, living in heaven, right? Like I have IDEs, I have classes, I have interfaces, I have libraries, I have unit tests, I have, we have a whole discipline that we've developed in the last 30 years on how to manage large complex systems, right? Like we decompose them into smaller pieces and create APIs and all that stuff. And suddenly I didn't have that. And the reality was that as you leverage more and more of the cloud, in this example was very extreme, but as you leverage more and more of the cloud, you basically move the logic of your application from your code to infrastructure, right? So in a sense, your application is not just the code that runs inside your Lambda function or inside a Docker image. Your application is both your infrastructure and the way your infrastructure is set up and the code that runs within those compute systems, which is not even the primary thing in a sense, right? Like that code reacts to events that the infrastructure emits. And so these event-driven, serverless, cloud-heavy, I call them because cloud-native I can't call them, but cloud-heavy.
Why not cloud-native?
What's that?
Why not cloud-native?
When you say cloud-native, people think you're using Kubernetes, right? Like it's kind of like...
Oh yeah, I suppose. Yeah. All right. I get you.
So I'm calling them cloud heavy. So these cloud heavy applications are not just infrastructure. They're not just code. They're also infrastructure. And being able to actually use programming languages to manage that complexity and to model those systems becomes a very, very useful thing. And so that's when basically I created this project that became the AWS CDK, which was the last thing I worked on at AWS in the last
So that was your initiative?
Yeah. Yes, it was based on that. It was based on me like being frustrated with YAML, basically.
And the Amazon CDK, how would you summarize that in just a sentence? What is the CDK? How is it different from, I suppose, the SDK?
So basically the CDK is the SDK for infrastructure, in a sense. It's a software development framework. So it's basically a library. Kind of like it has a composable programming model, kind of like React's programming model, where you can create these constructs and compose them together into more complex constructs. So you have this composability system. And when you run a CDK application, it synthesizes a CloudFormation template for you. So the output of a CDK program is a declarative desired state configuration of your infrastructure. Now, that's actually the least interesting thing about the CDK itself, because once you have these composability system, then suddenly you can create higher level APIs and abstractions, and you can create a whole universe of developer experience designed to give developers the ability to create complex infrastructure, complex systems, and model complex infrastructure systems and reuse them and share them through libraries and test them and all that good stuff that you can do in traditional programming languages, but now for your infrastructure. And so that's the CDK.
I see. So whereas the SDK gives you classes with a reasonable level of abstraction, so you can, for example, instantiate a client and provision a VPC, the CDK doesn't send off the API calls, but the end result is the YAML or JSON for CloudFormation, and also the classes are a bit even more higher class and allow for more, I suppose, composition with other services and resources as well. Would that be fair to say?
Yeah, I mean, the SDK is basically a way to interact with the backend systems. The SDK, the AWS SDK is generated off of the service definitions of the various backend systems. So if you have S3, and S3 has create bucket, update bucket, delete bucket, list objects, put item, blah, blah, blah. There's a bunch of APIs that the S3 service exposes. And the SDK basically allows it to call these APIs. That's the goal of the SDK.
Yeah.
And the CDK is designed to allow you to model the system. So you basically say, I want the system to have a bucket. I want the system to have a queue. I want the system to have a function, Lambda function. I want the function to be triggered when the queue has a message in it, or when a file is uploaded to the bucket. And when you run this thing, it produces infrastructure as code definition. And the infrastructure as code definition is going into a provisioning engine like CloudFormation or Terraform or Kubernetes and gets provisioned, right? Like that's basically the part where you set up the system. And once you've set up the system, it's executed and it operates. So yeah, that was a really fun project to work on. I loved every minute of it. It was kind of like this it became a very big open source project, and an incredible community kind of formed around it of developers who want to use programming languages to build cloud applications. It became very popular internally, because obviously the complexity was of systems that are built inside Amazon and AWS needed those tools.
Yeah, absolutely. Like you said, Amazon being its own best client.
Excuse me?
Sorry, there's a bit of lag. Yeah, like you said, Amazon being its own biggest client, and I suppose the advantage, which is a luxury that we often don't have otherwise, is that you can rely on your client actually giving you clear requirements for once. So you know that a solution being engineered at Amazon certainly fits one big use case, which is that of Amazon, and then is likely to also fit other use cases, which is kind of how I see the ethos of AWS. Like, it works for us. It could be useful to you.
And I would even emphasize it a little more, because Amazon doesn't have a culture of requiring internal teams to use certain tools. Like, it actually has a culture of like, you make your own choices about the tools that you're using to build your product. And that actually creates a situation where even if you're building something as AWS or as Amazon, you actually have to do a really good job in order for internal teams to adopt it. So it's not just, and I think like that creates this really natural alignment of incentives, right? Like you're gonna succeed only if there's a fit, right? Like if it actually fits the use cases, if it actually is loved by developers. And whenever Amazon had tried to like mandate teams to use certain tools, at least my experience internally was that they were not very good tools, right? Like, is they didn't create the right incentive for product teams to like build the right tool. So I think that's even more genuine in a sense.
Yeah, no, I see what you mean, in the sense of how embarrassing would it be for, let's say, AWS's S3 team if Amazon.com started using Microsoft's Object Store solution. So extra incentive to make sure that it is fit for purpose. So how does the communication internally work? Are there lots of events that facilitate communication between, for example, Amazon.com and their requirements, and initiatives then by AWS to see if there could be something innovative to fulfill those requirements? How does that work from a culture point of view?
So there is a top-down kind of process that goes every year between Amazon and AWS, and Amazon, the .com guys are listing their requirements and things that they need, but in most cases, there's nothing explicit about that, or there's nothing different between internal Amazon teams and any other company that uses AWS, or any startup company or any big company that uses AWS. And again, it goes back to this notion of like, you need to do your job. If you're building it, and then that's basically what happened with the CDK. I was like, I'm going to move to AWS and I'm going to build this as an AWS service. And if that's a good service, internal teams are going to adopt it. And so obviously we had a Slack channel, right, in the internal Slack, so people could ask questions about the CDK internally. And it had 17,000 people. But
that's a big Slack channel.
Yeah, right. That's a big Slack channel. And obviously, as you say, right, like you get this firsthand design partner, with people who are very opinionated, and they would not be shy to tell you. They would even go in the case of open source, they can just like naturally submit pull requests and improve your product, and that's an amazing. And now I know even more, right? Like how amazing that is as a vendor. But from a marketing and communications perspective, nothing special, right? Like you have to like go above the noise level like everybody else and make sure that people know about the project. And I remember, even 3 years into the CDK, I remember meeting solution architects, which are, their job is to basically get customers to know about AWS products, meeting solution architects that didn't know about the CDK. So chaos, basically, embracing the chaos.
Yeah. Well, this conversation was really interesting and really organic, a little too much even, because we've come to the 45-minute mark and we haven't even started talking about your current project, Wing, the programming language for the cloud yet. I would suggest, if you're up for it, we make this a spontaneous two-parter, and we make sure that we record the second part of the episode. So after this really interesting introduction and really good kind of jumping off point to understand why one would want a programming language for the cloud and all the parallels with the AWS CDK, we will record a second episode. Does that sound good to you?
Yeah, that'd be great.
Perfect. In that case, Elad, thank you so much for being on the show.
Thank you, man.
Cool. I think that was really good. I'm going to leave the recording going because why not? So yeah, is that actually cool with you? We'll because it 45 minutes. It was all interesting. I didn't want to. I tried to push like sometimes like okay, and then you moved on to Amazon. But then at Amazon you worked at a different project because I had my eye on the timer. But it was
carry on next.
Yeah,
next.
I mean but it is really interesting. So yeah, I think let's do that. Put something else in my calendar.
I will.
And we'll just make it a two-parter. I'm sure that Anchor won't mind. He'll be happy to have 2 episodes to release. By the way,
that would be great.
As of today, I got my badge today. I'm a solutions architect professional.
Oh, nice.
Yeah. And also, I don't know I've never used the CDK. Yeah.
Well, yeah. Maybe you'll be a Wing convert before you even use the C.
Yeah, I'm really eager to try it out actually. Yeah. But for now, I want to break because I had my exam yesterday, and
there's not a lot to try yet. It's still very early and very alpha, and
yeah.
But it's exciting. I'd be happy to.
Yeah, absolutely. I'll You have my calendar link. Just put something in my calendar, and then we'll record a second episode at some point.
Perfect. Sounds great.
Cool. All right, I'm gonna go and have some food because I'm supposed to be working this afternoon.
Enjoyed. Bye. See you later.